Okay, for this next section, we're going to be looking at polygons, which are just shapes, and their degrees. There's a couple things that we need to make sure we review that we learned earlier this chapter. And the first thing is that we already know that a triangle has 180 degrees. Um, we took a look at all different types of triangles. So we have right triangles, we have acute triangles, we have obtuse triangles, and what we determined is that the sum of the angles of any triangle is always 180 degrees. So we're going to need to use that piece of information today to figure out how many degrees do other shapes have. So our essential question is, how can the sum of the interior angles of a polygon be determined? And to understand this, we first need to look at the word polygon and understand, well, what is a polygon? So if we look right here, these are all polygons. All a polygon is it's a shape made out of straight lines that is enclosed. So you can see they all start and end at a point. They're enclosed. They don't have any lines that cross over, even though they could look really irregular like these bottom three here. So these are all polygons. What we're going to do today is we're going to figure out how many degrees does a four-sided shape have? How many degrees is a five-sided, six-sided, 7, 8, 9, 10, so forth shape have. These shapes are also all polygons, and they just don't look like a regular polygon like these ones up here, but they're still different sided shapes. So this one, for example, is a 1, 2, 3, 4, 5-sided shape. So this one right here with 5 sides would also actually be the same amount of degrees as this 5-sided shape up here. It's just that one of them looks regular and the other looks irregular, we call it. So let's jump into what we're looking at here. First of all, you have an activity sheet. You have these sheets right here. So on the front is the first part of the activity, on the back is the second, and then you have a second sheet of paper with a bunch of polygons on it. You're going to need both of those papers for the activity for today. So I'm going to start you off by walking through the directions so that you know what to do for the activity. So step 1, it says, using the page of polygons, split each polygon into triangles by drawing lines from one vertex to another. No lines may overlap or meet in the middle. Fill out the table below as you work through each polygon. So I'm going to do an example with you. We're going to do the 8-sided polygon together, and we're going to follow this direction here. Split it into triangles. So you're going to go to your polygon page, which would be this one. Find the 8-sided shape right there. And what it says is we need to break it into triangles. Now, it's very important that when you break it into triangles, you don't have any overlapping lines. So for example, I'm going to start at this vertex here, and I'm going to go like that, okay? Right now, this is not broken into triangles. This side is 1, 2, 3, 4, 5 sides. This is 1, 2, 3, 4, 5 sides. So I need to keep going. So a strategy is go back to that same vertex and draw another line to the next vertex. You can see here is a triangle right here. Okay, then go back to the vertex, draw another triangle. I have a triangle right here. Then this last one is already a triangle, so I don't have to break that up, but I need to go over to this side. I'm going to take my line, make another triangle. So this is now a triangle. And then right here, I have to split this into a triangle. So I have another triangle here, and then this last one is already a triangle. It's got 1, 2, 3 sides. So that's one possibility. That's one way that you could split it up. I'll show you a different way. So I could start like this, and I could keep breaking it like this. And then I notice that down here, I have a 4-sided figure. So I'm going to break it into, here's 2 triangles, okay? And then up here, I'm going to go like this, 2 triangles, and then in the middle, I'm going to break that up into 2 triangles. So both of the ways that I split this octagon into triangles would have been acceptable. Now, I'm going to show you what you cannot do. Okay, you cannot have lines that intersect. So you break it there, and then you go like this, and you tell me, hey, there's a triangle. No, it intersects right here. It cannot meet in the middle because we're going to measure the degrees of all these angles, and these degrees in the middle aren't actually on the outside of the shape. So you can't have any lines that meet or overlap like that. You also cannot go like this. Have a line stop in the middle, bring another one, say, hey, there's a triangle. There's a triangle. There's a triangle. And I'll do one more here. This is not an acceptable way to break it into triangles. You have to go from vertex to vertex. The reason is because when you stop in the middle, you're going to end up measuring these degrees, which are not on the shape. Okay, so right now you need to have your 8-sided shape, your octagon, split into triangles. If you don't have that, just pause, split it into triangles, and then push play. You can have whichever way you want as long as the lines do not cross over. Okay, now what we're going to do is we're going to go back to our table and we're going to fill in this information here. So the number of sides, the one we just did was 8. Then we're going to look at the number of triangles the polygon can be split into. So I'm going to need to go back to my octagon, okay, and I count how many triangles this was split into. So I can see there's 1, 2, 3, 4, 5, 6 triangles. So I'll record that it had 6 triangles in that shape. And then the sum of the interior angles, that's the total degrees of all of the triangles inside. Now what you need to remember is that each triangle has 180 degrees. So when we measure the angles, okay, this angle right here and this angle and this angle would all add to be 180 degrees. So that's 180 degrees right there. I can take any other triangle in this octagon, this angle, this angle, and this angle would also all add to be 180 degrees. Okay, so I'm going to put 180 degrees in all of these other triangles. And when I want to get the total of the degrees, I can see I would do 180 plus 180 plus 180 plus 180 plus 180 plus 180, or a different way would be 180 times 6, because there's 6 180s there. So if I get my calculator, 180 times 6 gives me 1080 degrees. So I'll go back to my table and I'll write the total was 1080 degrees. Okay, so what you're going to do is you're going to do the rest of the polygons on your sheet. So all of them on this page. You're going to record them on the table and finish step 1. Once you finish splitting these polygons into triangles and finding their degrees for the 4 through 12 sided figures, then you're going to go on to step 2, which is the bottom part of this chart. Now be careful, it says for step 2, for the polygons below, use any shortcuts or patterns you notice in the tables above to help you complete the table. These are not on the polygons page because they have too many sides. So you're going to have to look for some sort of pattern up here to figure out the degrees in an 18, 42, 37, and 50 sided figure. So that's step 2. And then step 3 is answering these 2 questions. So right now you need to go finish step 1, 2, and 3. And when you are done, then you'll push play again. So push pause and do step 1, 2, and 3. Okay, so you should have everything done on the front. And hopefully you made some pretty big discoveries on some shortcuts for polygons, especially when it comes to the one with like 37 and 50 sides. You don't want to have to draw those out and split it into triangles because chances are it's going to get really messy and you'll probably be inaccurate. So we're going to take those big discoveries you made and wrap it all up on the back of this paper. So if you flip to the back, you'll see the light bulb at the top and it has the main idea. So this is the main idea that you should have gotten. Okay, the main idea, how to find the sum of the interior angles of any polygon. So no matter how many sides it has, this is what you can always do to figure out the degrees. So you're going to go ahead and write this down. Step 1, you're going to count the number of sides on the polygon. Step 2, then you subtract 2. This is the number of triangles in the polygon because there are always 2 less triangles than the number of sides. This is true always for any shape. And then step 3, you're going to multiply the number of triangles by 180 degrees. That will give you the total degrees in any sided shape. Okay, so moving below, we'll do an example together. It says, find the sum of the interior angles of a 17-sided polygon. So this is a really big shape with a lot of sides, 17 sides. You're not going to draw out a 17-sided figure and split it into triangles. We're going to do the shortcut, which is these steps from above. So step 1, you're going to count the number of sides. There are 17 sides. Step 2 then, you need to subtract 2. So when I do 17, take away 2, that's 15. Then step 3 says we need to multiply the number of triangles. This would be there's 15 triangles by 180 degrees. So 15 times 180, and if I use my calculator, I can see that that is equal to 2,700. So in a 17-sided polygon, there would be 2,700 degrees. Okay, you're going to do the same thing for these next 6 polygons. So go ahead and use the same process for all of these different sided figures. You'll want to use a calculator. You could use the one on your laptop. Once you have these 6 done, you're then going to go to Google Classroom and complete the ticket to go. This will tell me how well you're understanding things because I will check your responses on the ticket to go online, which I can see, as opposed to I cannot see what you are working on at your desk when I am not there. So go ahead and do the ticket to go on Google Classroom, and then there will be an additional step if you have time. So right now you can end the video and do these 6 problems.